Welcome back, Play Basic Coders. Let's take a look at this rectangle to rectangle code that was posted on the forums. First we'll run it and we'll have a talk about it. As we move over, I'm controlling the white rectangle and we're drawing a second rectangle there. What it's showing us there is how we would cut the background up into multiple rectangles that don't overlap the white rectangle in the foreground. If we change the white size, for example, you'll see there's different. I'll unhook that. You'll see there's different situations where. So when we're in this case here, we would output two rectangles that go around the side of the white here. So if we were going to be drawing these things as layers, we could calculate what part of the background needs to be drawn, and then only drawn the part that needs to be drawn and ignore the overlapping parts, which is pretty important if you want to have a balanced performance with lots of this overlapping stuff. Just randomize the scene when you hit spacebar. What the values at the top there are showing us, this is the state of the two rectangles are in, and so the top bit there represents if this left edge here is compared to the left edge of the one behind it. We have a bit control, so if it's equal or greater, it's set. If it's less than, it's 0. Same goes for the right edge to this right edge here, and that's represented by this bit up here. So that gives us 4 possible combinations that these two spans will cover horizontally. And vertically it's the same thing. We're doing exactly the same thing, but we're using the two bottom bits there. So the top of the foreground is compared to the top of the background. If it's higher, set to 1. The bottom of the foreground is compared to the bottom of the background. If it's higher, it would be 1 as well, but it's not. It's lower than the background. So that just turns the whole problem into a set of known results, pretty much, or known regions. But mostly what I wanted this to do is to work out just what regions are visible depending on where the foreground rectangle or square is, actually. I think we've done all 16. So some cases are very simple, where, like that there, for example, where the foreground's moving down and we end up with one rectangle output, which is perfect. As we move down further, we end up with 2, a top portion and a bottom portion. Look at the code. Just basic setup, load of fonts, define a rectangle for us. We're not actually using that at the moment. Oh, sorry, we are using that to output the rectangles too. So we're creating one rectangle going into the clipping function, and it's outputting multiple rectangles for us. Main loop, just for display purposes. The back represents the rectangle at the back. We're giving it a random location. So we're just giving it computing a width randomly, working out a bit of a location for its top left-hand coordinate, writing those into our structure, we're giving it a random color, doing the same thing for the front pretty much. Defining the front. I think we're attaching this to the mouse, so I'm just doing this inside the inner loop there. The assumption is that the mouse is, it can't be detected during that first iteration. I've logically made that impossible, so this is preset to true when the program starts. So it has to initialize this, and then after that, if the mouse was pressed when the app started, we can flip-flop it on or off. That just means I can detach the foreground square or rectangle from the mouse. So when I was testing it, it was kind of handy. When I published the demo before, I actually cut this version from another larger program and realised I'd left that out, but there you go. Of course, there are situations where the foreground there, trying to get it's randomised, there you go, is completely occluding the background, so there's nothing being outputted in that situation. So we've got a bunch of cases there where nothing needs to be done. If they're not overlapping, we don't care. We only care when they both share some space. Like we're using rectangles here, but they could be images, of course. Anyway, have a look at the clipping thing. So this is all just set up here. We're just clearing the screen, drawing the background box, moving the foreground box if we need to, detecting if the mouse is pressed to detach the mouse to the box, drawing the foreground box. So all those things are drawn up front. Then we do our clip rectangles, and we're just returning how many of these rectangles were created from the intersection. Down at the bottom here, we're passing in the front rect and the back rect. Just a bit of checking there to make sure we're passing in something that is actually allocated, in case we pass in something that's null. In this case, that's irrelevant, but anyway, we're checking if the right-hand edge is to the left of the background. In other words, they can't possibly intersect. Doing the same thing for the opposite side on the x-axis. We're checking if the left-hand edge is beyond the right-hand edge of the background. They can't intersect. So we just eject, go back. Check at the front, it's above or below, same principle. Here's where we're doing the bit pattern comparisons. We're comparing the front left edge to the front, the back left edge, and using that to make a bit pattern. What we end up with is a 4-bit number, and each bit represents the orientation, or its position relative to the back, the front to the back. So the front, when the foreground on the left is set, that means it is this x coordinate here is on, it's to the right of the background of back x1, which is the left hand edge of the back rectangle. Do the same thing for the other edge. We compare those two edges together, so we have a bit that represents those two. Same for the vertical axis. This builds up this combination of 16 possible outcomes. We just go through, select case, and just solve each one directly. There's no intersections, no nothing. We're just going, all right, if the foreground is in this location and the background's at that location, then our bounding areas, our visible areas are going to be these. In that case there, the foreground's overlapping the background completely, so we don't need to do anything. And that's the case where we've got the smaller block in front of a larger block that creates the 4 output zones. Probably having a table is probably useful in some regards, where you can have a generalized routine and then pass it what kind of clipping table you wanted to use. So you could have the same comparisons, but the output be different depending on what you wanted. Let's say you only ever wanted rectangles to be created on the right hand edge of something, or for some other reason, or you wanted to output when the two tables overlap, the part of the rectangles where they overlap as well. So rather than just clipping the front to the back, we can do it to the foreground here as well. We could have this zone here be one that would be drawn in white. If we were adding the two colors together, for example, if we had our white rectangle and our brown rectangle and we're doing alpha addition, we could pre-compute the addition, we'll then work out the area that's overlapping here and just draw that in the new color without ever doing fetching the background color. No need to. You can just do that same thing but if you clip the foreground to the background block and get the region that you're overlapping and just draw that in a new colour, of the two colours blended, that would give you the illusion you're doing alpha blending. I was sort of mainly thinking more about stuff like interfaces kind of stuff, you know, working out what regions you need to draw and then going, okay, I'm going to draw my scene and this portion of the scene there and put a viewport around the back of that and then draw that section and then stop drawing when you enter it and exit it. That would be pretty handy. But all kinds of situations you can use it for, I guess. This kind of idea anyway. Anyway, solution's very simple. It's a mechanical solution. We just got all of the zones pre-computed for you. If you want to make it different, go and make it different. Have fun with it. That's the idea. You know, if you can find a use for it, find a use for it. Thanks for listening, and I'll see you next time. Bye. Thanks for watching, and if you want more programming content, please subscribe to playbasic.com.